Hi, my name is Ashley Culver, and I'll be talking about the dilution and streaking method, what they're for, and how to use them. If I'm going too fast, go ahead and pause the video. I promise I won't mind. And if you prefer to read the written script, I'll leave a link in the description below to its Google Doc. So why use the dilution and streaking methods? The purpose of these methods is to observe bacterial growth in a way that's quantifiable. These methods space out the bacteria enough for different strains to be identified, too. And these things sound simple, but because bacteria grow so prolifically, it's difficult to spread the bacteria thinly enough to count the colonies. Enter dilution. Serial dilution is the movement of a 1 milliliter sample into 9 milliliters of distilled water. A milliliter of this solution is then taken and added to the next 9 milliliters of distilled water, and so on. As implied by the name, this creates an increasingly diluted product so that the colonies that grow are distinct, spaced from one another, and hopefully not in the hundreds. This is an example of why you wouldn't want to use the dilution method by itself. This is actually a lab that I ran on May 17th, where I thought if I diluted the sample to 1/1000th its original concentration, I'd have a number of colonies I'm actually capable of counting. And as you can see, there's no way that this is quantifiable. I ended up having one big colony on my petri dish, which is called a lawn. Moving on now to streaking. Streaking is the use of an inoculation loop, aka an isoloop, to streak a petri dish using a specific pattern. The pattern used is designed to space out the colonies in a specific section of the dish. Now for the how-to part of this video. Let's start with dilution. First, you'll need to swab your sample with an isoloop and then dilute it in 1 milliliter of distilled water. We'll call this test tube 1. And if you're doing this with a 1/1000th dilution like I did, you'll need 4 test tubes per sample. Once your sample is diluted in the 1 milliliter of distilled water, you're going to add 9 milliliters of distilled water to test tubes 2 and 3 and 4. Using a sterile pipette, you'll measure out 1 milliliter from test tube 1, and you'll empty that out into the second test tube to make a 1/10th diluted solution. You'll want to cap the tube and shake it gently, and discard your pipette. Using a new sterile pipette, measure out 1 milliliter from the second test tube, and dispense it in the third test tube. And this will make a 1/100th diluted solution, and shake it gently. Get a new pipette and measure out 1 milliliter from the third test tube, placing that milliliter in the fourth test tube, and once you've shaken it up a bit, you'll have a 1/1000th diluted solution. You want to repeat steps 1 through 5 for any of the remaining samples. Alright, let's move on to streaking. Using graph paper, draw an X that's at least large enough to cover the petri dish that you're using. Place the dish so that its center is over the middle of the X. This divides the dish into 4 quadrants. Select one of the quadrants as your starting position. Dip your isoloop into the 1/1000th diluted solution so that there's a film covering the loop, kind of similar to a wand you use for blowing bubbles. And holding the isoloop at a 45-degree angle, streak the plate from the tip of the quadrant to the outermost region using a zigzagging motion. Rotating the paper if needed, streak the second quadrant, dragging the isoloop into the first quadrant partially, and then returning it to the second quadrant. Repeat these steps with the third and fourth quadrant. So going from the inside, taking from the last one, starting over, from the inside to the outside, looping back to the previous. Okay, and once your bacteria grows, your streak pattern should be visible and it'll look something like this. And you can use this process as needed for each sample, and obviously you'll want to correspond the sample with their petri dishes. And that's all there is to it. Good luck to you, and may your bacteria be as quantifiable and colonized as it was intended to be.